Okay, so section 10.2 is what we're working on today, and I need you to understand that the term arithmetic is going to mean that we are either adding or subtracting. And what I mean by that is the same number every single time. So we could be adding 5, we could be subtracting 3. So for instance, if you look down at question 2, determine if the given sequence is an arithmetic sequence. An arithmetic sequence has something called a common difference. That's what you're either adding or subtracting. Well, it looks like this one is going down. So we want to find a common difference by taking any term and subtracting the previous term. And I don't think I wrote that one very well. Any term minus the previous term. Well, in this case, that would be -3. Now, we should be able to do that. Any term minus the previous term. Any term minus the previous term. Since we're getting the same number every time, that is our common difference, -3. So the answer is yes. I'll come back to question 1 here in a second. The common difference is -3. What about the one below it? Does that have a common difference? Sure it does. It's going up by 1 each time. Now, question 1 asks about arithmetic sequence. Or a missing term, I should say. A missing term is going to be found by understanding that you are adding that common difference not just once, but twice. So we're starting with the 2, and we're adding the common difference twice to get 26. Well, if you solve this, here's what you're going to find out. We're going to push this to the other side, right? Alright, so we could move that off the list, bring that over. 2d equals 24. Divide by 2. Well, that means my common difference is 12. So if I take 2 and I add 12, I get the middle term, which is 14. Now I got another way of doing this besides that. I'll use blue for this. If it's a middle value, you could just average the two numbers together. The 2 and the 26. And if we average them, add them up, we get 28 over 2, and 28 over 2 is 14. So the average, it's called the arithmetic average, is probably the faster way to go with that. Okay. Remember, I talked about 2 different types of sequences. Explicit and recursive. And I said recursive, I would never want to find the 500th term because that would take forever. Explicit, I can go straight to the answer. Well, the explicit formula that we're going to write out here, the nth term is equal to a sub 1, the first term, plus the common difference times n minus 1. Now you have seen a very similar formula. It's going to look like this. Y equals y1 plus m times x minus x1. That is the point-slope form of the equation of a line. Okay? Now, if I go through this process, a sub n equals first term 7. Common difference. Looks like we're only going up by 7. Now, we want to know 110. So we're looking for a sub 110 equals 7 plus 7 times 110 minus 1. We'll pause and see what we get on our calculators. Okay, so question 7. A theater has 44 seats in the first row, 46 in the second, 48 in the third, and so on. So the common difference, right, as you're going from one to the next, is easy to see that it's a 2. How many seats are there in row 20? So we want to know the 20th row. So we have the first row plus the common difference between rows times 20 minus 1. So let's see here, that's 19 times 2, that's 38, plus 44, so we end up with what, 70, 82. Now, question 8 says find the 17th term of the sequence, given that we know that the 18th term is -4. Okay, so you've got the 17th term, then you've got the 18th term of a sequence, and so this one's -4. Now think. We want the 17th term, a sub 17. So we're going to be going backwards. If the common difference is to subtract 11 every time. So minus 11, minus 11, minus 11. Going up would be to add 11. So if you could take 11 plus -4, you get 7. Oh, sorry kids, I was getting sleepy here, 1 in the morning. Okay, question 9 is actually pretty easy. Question 9 is saying, okay, you've got some term. There's actually 3 terms. This one is a sub n plus 1. This one is a sub n minus 1. This is a sub n. So it looks like they give me the one on the right, -3, and then the one on the left is 5, and they want to know how to find the middle one. Well, this is where we talked about adding the 5 and the -3 together and dividing by the number of values that you have. So 2 over 2 is 1. Okay, so the explicit one's going to be pretty easy, right? A sub n equals first term plus common difference. Looks like it's all going up by 5. Times n minus, oh, what do we got here? Is it n minus 1? First term is 0. Yeah, we do. That's an explicit version of this. all I'm doing is using the point-slope form that we talked about before. And I'm throwing in the common difference and the first term. Now the recursive formula, remember, has two parts. You have to identify the first term, and then you have to give it a way. So that would be a sub n minus 1 plus how much are we adding each time? We're adding 5. So there's your recursive formula for that. Find the missing terms of the arithmetic sequence. I'm going to leave that one for you. They give you a hint. This is the arithmetic mean of the first and the fifth is the third. So you'll actually find this first, because there's a lot of typing on the calculator. You want to be careful on how you type it in so that you don't make a mistake. But it shouldn't be that hard. Okay. I'll let you worry about number 12 also. Let's see what we got for 13. In an arithmetic sequence, with the first term being 25 and the common difference being -5, which term is 10? So in this particular question, you're starting down the path, first term 25, common difference -5. And which term is the 10th term? Oh, I put the 10 in the wrong spot. Stop me, that's terrible. The 10 is the actual value of the term. So they want me to go backwards. So if I push this to the other side, that'd be -15 equals -5 times n minus 1. Divide out the -5. N minus 1 equals 3. So if you add 1, that makes n equal to 4. So that one, they gave me the term. They just didn't know which order it was in. Which, given the two terms of the arithmetic sequence, find the first term and the common difference. Ugh. So if that's the fourth term, we have 5th, 6th, 7th, 8th, 9th. And the 9th term is -10, right? That's the 9th one. And the 4th one was 35. What's the common difference? Well, how many times? 1, 2, 3, 4, 5. So 35 plus 5 common differences equals -10. And that's what we need to be solving. So subtract the 35 over to the other side. 5d equals -45. So to get d by itself, we divide by 5. d equals -9. That's the common difference. Now that we know the common difference is -9, how could we use it to go? Okay, so had to make a change because I screwed up the first time I did this example. So this is my edit. We know in this particular problem that you're subtracting 9 each time to move in the forward direction. But what do you do to go backwards? You have to do the opposite. So the first time I did this, I screwed up and I subtracted. I think I was too tired, actually. But so I would add 9 to the 35 and get 44. Add 9 again and get 53. add 9 again, and get 62. So the first term of this entire sequence was 62. So that's what I should have done when I was doing this problem before. All right.